Hello everybody, welcome back to High School Tutoring. I'm your host Manny, and today we're going to be talking about force equations. So, the idea of this is going to be, we're going to be taking elements from these three videos. We have FDB equations, we have free body diagrams, and we have finding friction. We're going to take all those elements and put them into this video, but instead now we're using variables and numbers, so we're going to be finding specific equations, and we're also going to be finding friction as shown from this one. And yeah, so let's just get started, and I'm going to be explaining the process on how to use all three of these and put them in elements with actual numbers. So let's take a look here. So we're going to have to, for each of these, we're going to have to draw a free body diagram and then draw equations, and we're going to be finding friction for the third one only. But here we go. You know what? Let's just begin. So let's start by taking a look at this first problem. First problem that we have here, and we have three boxes: M1, M2, and M3 are next to each other on a table from left to right. Force is applied to the right on M1. What is the acceleration of the system? So they're on a table, so we can just draw our ground. We have a box M1. So M1. We have a box M2. I have a box M3. So I drew this really badly, but all these should be next to each other, so this should be touching, but besides that. And there's a right force on M1, so there's that. We have force. And this is on a table, and we still have F gravity. And that means that we have a normal force on all of these, so I'm just going to do this to represent the entire normal force. These should be the same, which in this scenario there should be, but yeah, this is the normal force for all of these, and they all have a force of gravity on them. So what we have to find is the acceleration of the entire thing. So if we imagine our horizontal problem, meaning if we do this, the net force, or F net, is equal to ma, and we can imagine that right is positive because of the idea of having just acceleration, of like it accelerating to the right. That would be how we find ma. So the idea is we're taking this for each one of these. So net force, so for M1, M2, and M3 is all equal to ma. So that would be M1A, M2A, M3A. So using mass of 1, mass of 2, and the mass of 3. So that means, and since we only have one force that we're counting, because horizontal and vertical we're separating, that would just be F. Let's do F applied, because that's what this technically is. So I'll draw that again, just like that. And we have F applied is equal to M1A, M2A, or plus these, and M plus M3A. That's how that looks. So the idea is we want to find acceleration, which is how we're looking for it. And since we don't have a numerical value, what we're going to do is we're going to actually factor out A. So you see we have mass 1A, mass 2A, mass 3A. None of these variables we don't think they are, because of their subvariant, aren't going to be the same. So let's factor out A. So we have F applied. We just have that we still have that on this side. And that means that we're going to have A, and then in parentheses M1 plus M2 plus M3. So that's how we're going to factor it out. And now we have M1 plus M2 plus M3. And if we want to just isolate A, we just divide the entire thing by M1 plus M2 plus M3. And now that'll just go on the other side. So M1 plus M2 plus M3. And that means that's acceleration equals. So that means that A is equal to this. There you go. That's how you solve the first one. So we're bringing in free body diagrams by drawing this. We're bringing in FBD equations by putting this out. And we're not finding friction yet. So now let's continue here. So if it's being pulled horizontally, we can imagine we're just going to have a box. We're going to have F grav. So we can have the force of gravity or mg. You can have either one. They're the exact same. Then we can have Fn. So we have our net force, or not a normal force is what we have. And so it is being pulled horizontally. So that means it's being pulled. We can just assume to the right. It doesn't really matter. So we have a 325 Newton pull. And we want to find friction. So we want to find F of F. And it has a mass of 200 kg, and it is accelerating at 1.5 meters second squared. So that is how we're looking at it. There we go. Okay, so that is how we're looking at it here. It's accelerating, well, from what we're assuming, it's accelerating to the right at 1.5 meters per second squared. It weighs 200 kilograms, or its mass is 200 kilograms. Its weight is F grav. It's being counteracted because it's not free falling, but it's not free falling. So a normal force is applied to keep it in place, and it has a frictional force that we must find. So first thing we can do is obviously check to see if there even is a frictional force. Even though it's asking us to find it, we may as well check anyway. So that means what we do, since we have F equals ma, that's how we find that. So we're just going to divide by m, so that means F over m is equal to a. So we have 325 divided by 200 is equal to a. So that's equal to, that's equal to 1.625. There you go. So that clearly is not equal to 1.5. So 1.5 is not equal to 1.625. Those are not equal to each other. So what we're going to do now is we're going to use these two. If we're still using F equals ma, we're now going to multiply its mass times acceleration that we're given. So that means 200 times 1.5 is equal to our force, or our F net is what it's equal to, and that is equal to, so let's see, 200 times 1.5, that's equal to 300. So we're looking for a net force of 300 newtons. Looking for a net force of 300 newtons. And so if it's being pulled at 325 and the net force is 300, how do we find the frictional force? I think we should just subtract it from each other. So 325 minus 300 is equal to 25 newtons, and that means our frictional force is equal to 25 newtons. So we can write that there, and that's it. So if you want to check your work, we obviously, so we have F net is equal to ma. We have 325 minus 25. Should also assume that right is positive, it's accelerating. So, and that is equal to ma. Or 1.5, no, other way around. Or 200 times 1.5. So we have 300 equals 300, and that is correct. So that's how you check your answer. And now we know that 25 newtons is our frictional value. So I hope you guys enjoyed this video, because this is really something that people don't really put into retrospect. Like, they figure out how to put the equations together, but they don't really know how to do the math. So yeah, I'm gonna leave a couple cards up a little earlier in the video to kind of like diagram at which part that each of these are being like used at. And so yeah, I hope you guys enjoyed, and I'll see you guys in the next one. Bye bye.